Good morning to all. This is Dr. S. Harnath Babu, Assistant Professor of Physics, Namacharya Institute of Technology and Sciences, Rajampet. Now I discuss the dipolar or orientational polarization. So certain molecules have permanent dipole moment. Such molecules are called polar molecules, and corresponding dielectric is called polar dielectrics. So some type of materials having polarization, spontaneous polarization. So in that molecules, positive charge center, negative charge centers are separated. So there is a permanent dipole moment. So that type of molecules are called polar molecules. That type of dielectrics are called polar dielectrics. So in the absence of electric field, all dipoles in the polar dielectrics are at random orientation. Then net dipole moment becomes zero. So in above figure, we can explain the first diagram. You take first diagram. This is the first diagram. So there is no application of electric field. So on the capacitor plates, there is no charge. So here we are taking one dielectric material between two capacitor plates. So there is no charge on the capacitor plates. Then these polar dielectric has permanent dipole moments. Each molecule has permanent dipole moment, but all dipoles are oriented in different directions. So one molecule dipole moment is cancelled by the other molecule dipole moment. So net dipole moment becomes equal to 0. When electric field is applied, the dipoles are rotated about their axis of symmetry and aligned in the direction of electric field. The dipole alignment is counteracted by the thermal agitation. So here we can explain this by using the second diagram. So in this, these capacitor plates are charged. First capacitor plate is positively charged. Second capacitor plate is negatively charged. We keep the dielectric material between two capacitor plates. Then, due to the application of electric field, these molecular dipoles are rotated in the same direction of electric field. Then the net dipole moment becomes more. Then this type of polarization is called orientational polarization or dipolar polarization. So in the dipole alignment is counteracted by the thermal agitation. In electronic and ionic polarizations, the restoring force will be developed. So here in dipolar polarization, thermal agitation is developed. So orientation polarization depends on temperature, thermal energy randomizing the dipoles. Orientation polarization takes longer time, 10 power minus 10 seconds, than the electronic and ionic polarizations. So orientation polarization, PO is equal to capital N into mu naught, where capital N is the number of molecules per unit volume. Mu naught is the orientation polarization of one molecule. P naught is equal to capital N mu square E by 3 kT, where mu is the dipole moment of one molecule, N mu square E by 3 kT. The orientation polarizability alpha naught is equal to P naught by Ne. Alpha naught, orientation polarizability alpha naught is equal to mu square by 3 kT, where mu is the permanent dipole moment of one molecule. Next, internal field or local field. Let a dielectric is placed between the plates of parallel plate capacitor. Let there is an imaginary spherical cavity around an atom A inside the dielectric. The internal field at the atom A is made up of 4 components. Internal field is equal to E1 E plus E2 plus E3 plus E4. So here we are taking two capacitor plates. These two capacitor plates are connected to the battery. One capacitor plate is positively charged, other capacitor plate is negatively charged. Between two capacitor plates we are keeping one dielectric material. So here at the center of the dielectric material we are choosing capital A, one atom. Around the atom A, we are choosing one imaginary spherical cavity. So internal field is the resultant electric field acting at point A in the dielectric material. So we can calculate field capital E1. E1 is the electric field intensity at capital A due to the charge density on the plates. From field theory, E1 is equal to D by epsilon naught, where D is dielectric constant or electric flux density. Epsilon naught is the permittivity of free space. D is equal to epsilon naught E plus P. Already from definition we can write this formula. So by using these two formulae, we can write E1 is equal to epsilon naught E plus P by epsilon naught. Then E1 is equal to E plus P by epsilon naught. This is equation number 2. Where at point A, due to the E1 is the electric field intensity at A due to the charge density on the capacitor plates. Next, field E2. E2 is the field intensity at point A due to the charge density induced on two sides of the dielectric material. So if you keep the dielectric material between two capacitor plates, then the dielectric material is polarized. The opposite charges are induced on the surfaces of the dielectric material. So here this capacitor plate, first capacitor plate is positively charged. So near the first capacitor plate, on the surface of the dielectric material, negative charges are induced. So on second capacitor plate, negative charges are induced. So near the negative charged capacitor plate, on the dielectric material surface, positive charges are induced. So due to the electric field is due to the charge density on surfaces of dielectric material, some electric field is acting at point A, that is taken as E2. So E2 is equal to minus P by epsilon naught. P is the polarization vector, epsilon naught is the permittivity of free space. Field E3, electric field E3. E3 is the field intensity at capital A, center atom A, due to the other atoms contained in the cavity. We are assuming the spherical structure, symmetric structure, so E3 is equal to 0 because of symmetry. So here in the spherical cavity we are assuming the spherical cavity. So inside the spherical cavity there are positive charges and negative charges, because due to the application of electric field, the positive charges and negative charges are separated. The dielectric material is polarized. So inside the sphere, the positive charges or negative charges are there. Due to that charge density, the electric field is acting at point A. But we are taking spherical material, spherical cavity. So that is in symmetrical shape material cavity. So the electric field becomes equal to 0. So E3 becomes equal to 0. Next, E4. E4 is the field intensity due to polarization charges on the surfaces of cavity. So on the surfaces of cavity, the charges are induced. So in left side of the dielectric material surface, negative charges are induced. So near to that negative charges, opposite charges, positive charges are induced on half of the surface of spherical cavity. In right side, on the dielectric surface, positive charges are there. So near to that, opposite charges, negative charges are induced on the spherical cavity surface. So due to the charge density on surface of spherical cavity, there is E4 electric field is acting at point A. So here we are calculating that E4 value. So we are taking the spherical cavity in left side half of the spherical surface. Half of the spherical surface, positive charges are induced. In right side of half of spherical cavity surface, negative charges are induced. So here we are considering that we are taking one spherical strip. So here QR is the spherical strip we are considering. So we are drawing spherical strip and we are taking radius. AQ is the radius, AR is also radius. So the angle between AQ and AP is theta. Next, the angle between AR and AQ is d theta, such that the spherical strip is considering, QR spherical strip is considering. So if dA is the surface area of the spherical shell of radius r lying between theta and d theta. So QR is the spherical strip or spherical shell that is lying between theta and d theta. So then we are calculating area, surface area dA is equal to 2 pi into PQ into QR. So by using the triangle APQ triangle, then we can calculate sin theta is equal to opposite side PQ by hypotenuse AQ. AQ value is equal to R. So sin theta is equal to PQ by R. Then by taking cross multiplication, PQ is equal to R sin theta. Similarly, next we can write that d theta value. D theta is equal to QR by small r radius. Already you know the formula, arc QR is equal to R d theta. QR is equal to R d theta. So next, hence we can calculate the surface area dA is equal to 2 pi r, PQ value is equal to sin theta into QR value is R d theta. So surface area dA is equal to 2 pi r sin theta into R d theta. The charge dq on the surface dA is equal to the normal component of polarization multiplied by the surface area. So here already in the diagram, already we can observe that on the spherical cavity we are taking spherical strip. So the polarization is along horizontal direction or along positive x direction or in the direction of electric field. So on the spherical cavity surface, the normal component of polarization is taken, that is taken considered as Pn. So that Pn value is equal to P cos theta value. So that is substituting. So dq is equal to normal component of polarization P cos theta into surface area of the spherical shell dA. So substitute equation 5 in equation 6. dq is equal to P cos theta, dA value is equal to 2 pi r sin theta into R d theta. Then dq is equal to P into 2 pi r, r into r square. So 2 pi r square sin theta cos theta d theta. The field due to charge dq on capital A is denoted by dE4 in the direction theta is equal to 0 or along positive x direction. So dE4 is equal to dq into 1 into cos theta by 4 pi epsilon naught r square. So dE4 is equal to dq value is P cos theta into 2 pi r square sin theta d theta cos theta by 4 pi epsilon naught r square. So dE4 is equal to 2 pi gets cancelled, 2 2 4 gets cancelled. So P by 2 epsilon naught into cos theta cos square theta into sin theta into d theta. The total field due to surface of entire cavity is integral dE4. So if you integrating above equation, then you get total field due to the surface cavity acting at point A. That is integral dE4 is equal to P by 2 epsilon naught integral 0 to pi cos square theta sin theta d theta. Then integral dE4 becomes E4, that is equal to P by 2 epsilon naught into integral 0 to pi cos square theta d of minus cos theta. So sin theta d theta can be written as d of minus cos theta. Next, that is equal to sin minus into common minus P by 2 epsilon naught into, by integrating this value, then you get with respect to cos theta, we are integrating this term, then cos cube theta then cos cube theta by 3, the limits are from 0 to pi, then that is equal to minus P by 3 into 2 6 epsilon naught into cos pi is equal to minus 1 minus cos 0 is equal to minus 1. So E4 is equal to P by 3 epsilon naught. So minus 1 becomes minus 2, minus into minus plus 2, 2 3 is 6. So then we get P by 3 epsilon naught. So that is equation number 8. The internal field EI is equal to, you can add all these terms E1, E2, E3, all the equations. So E plus P by 3 epsilon naught. So here you can add all these values.